you are correct that fuses are adequate overcurrent devices for alternating current service. The National Electrical Code, often abbreviated as NEC, does not require the replacement of fuse panels with breaker panels in existing dwellings. Fuse panels are still widely used and are considered safe and effective when properly installed and maintained. However, there are some advantages to using breaker panels over fuse panels. Firstly, convenience is a factor. Circuit breakers can be easily reset after a trip, while fuses need to be replaced. Secondly, safety is something to consider. Circuit breakers can provide better protection against electrical fires, as they are designed to trip faster than fuses. Finally, modernization is a superficial consideration. Breaker panels are more modern and aesthetically pleasing than fuse panels. It is possible that the person who told the homeowner that they need to change their fuse panel to a breaker panel was simply unaware of the code requirements. It is also possible that they were referring to local or insurance company requirements. Some insurance companies may require the use of breaker panels in newer homes. Ultimately, the decision of whether or not to replace a fuse panel with a breaker panel is up to the homeowner. There are pros and cons to both types of panels, and the homeowner should weigh their options before making a decision. Now, let's delve a bit deeper into the technical aspects of fuses and circuit breakers and why this discussion even arises. Both fuses and circuit breakers serve the same fundamental purpose to protect electrical circuits from overcurrent conditions. Overcurrent can occur due to a short circuit, where there is an unintended low resistance path for current to flow, or an overload, where too many devices are drawing current from the circuit. Without overcurrent protection, the wires in the circuit could overheat, potentially causing a fire. A fuse is a simple device consisting of a metal strip or wire that melts and breaks the circuit when the current exceeds a certain level. The fuse is designed to be a weak link in the circuit, so it will fail before any other components are damaged. Fuses are rated in amps, which indicates the amount of current they can carry before blowing. When a fuse blows, it must be replaced with a new fuse of the same rating. A circuit breaker, on the other hand, is a more complex device that uses a mechanical mechanism to interrupt the circuit. Circuit breakers typically use a bimetallic strip or a magnetic coil to sense overcurrent. When an overcurrent is detected, the bimetallic strip bends or the magnetic coil pulls a lever, which trips the breaker and opens the circuit. Circuit breakers can be reset after they trip, which is one of their main advantages over fuses. Circuit breakers are also rated in amps, and they are available in a variety of types to suit different applications. Now, let's consider some more specific advantages and disadvantages of each type of overcurrent protection. Fuses are generally less expensive than circuit breakers. This is because they are simpler devices with fewer components. Fuses can be more reliable than circuit breakers in some cases. Because they are simpler, there are fewer things that can go wrong. Fuses can offer better short-circuit protection. Some types of fuses, such as fast-acting fuses, are designed to trip very quickly in response to a short circuit, which can help to minimize damage to equipment. However, fuses have some disadvantages as well. They need to be replaced after they blow, which can be inconvenient. It can be difficult to determine the cause of a blown fuse. Sometimes the cause is obvious, such as a short circuit, but other times it may be necessary to troubleshoot the circuit to find the problem. Fuses can be less accurate than circuit breakers. The melting point of the metal strip in a fuse can vary slightly, which can affect the current at which the fuse blows. Circuit breakers also have their advantages. They can be reset after the trip, which is more convenient than replacing a fuse. They provide a visual indication of whether they have tripped. This can make it easier to troubleshoot electrical problems. Circuit breakers can be more accurate than fuses. They are designed to trip at a specific current level, and they are less likely to be affected by variations in temperature or other factors. However, circuit breakers also have some disadvantages. They are generally more expensive than fuses. They can be more prone to nuisance tripping. This can occur if the breaker is not properly sized for the circuit, or if there are voltage fluctuations in the electrical system. They may not provide as good of short-circuit protection as some types of fuses. Now let's consider the National Electrical Code requirements for overcurrent protection. As mentioned earlier, the NEC does not require the replacement of fuse panels with breaker panels in existing dwellings. However, the NEC does have specific requirements for the installation and maintenance of both fuses and circuit breakers. For example, NEC Section 240.6 specifies the standard ampere ratings for fuses and circuit breakers. These ratings are designed to protect the conductors in the circuit from overcurrent. NEC Section 240.20 covers the installation requirements for overcurrent protection devices. This section specifies that overcurrent devices must be readily accessible and must be protected from physical damage. NEC Section 240.40 covers the enclosure requirements for overcurrent protection devices. This section specifies that overcurrent devices must be enclosed in a cabinet or cut-out box that is designed to protect them from the environment. In addition to the NEC requirements, there may also be local codes or insurance company requirements that apply to overcurrent protection. It is important to check with your local authorities and your insurance company to determine what requirements apply in your area. Now let's talk a bit about sizing overcurrent protection for different types of circuits. The general rule is that the overcurrent protection device should be sized to protect the conductors in the circuit. This means that the amp rating of the overcurrent device should not exceed the ampacity of the conductors. The ampacity of a conductor is the maximum amount of current that it can carry safely without overheating. The ampacity of a conductor depends on several factors, including the size of the conductor, the type of insulation, and the ambient temperature. NEC Table 310.15b16 provides ampacity ratings for various types of conductors. For example, a 14 American wire gauge copper conductor with type THHN insulation has an ampacity of 15 amps at an ambient temperature of 30 degrees Celsius. Therefore, a 14 American wire gauge copper conductor with type THHN insulation should be protected by a 15 amp overcurrent device. However, there are some exceptions to this general rule. For example, NEC Section 240.4d allows for the use of a 20 amp overcurrent device to protect a 12 American wire gauge copper conductor in certain situations. This is because 12 American wire gauge copper conductors have an ampacity of 20 amps at an ambient temperature of 30 degrees Celsius when used in certain applications, such as branch circuits that supply receptacles. It is important to consult the NEC and any applicable local codes to determine the correct size of overcurrent protection for a particular circuit. Now, let's discuss some common problems that could occur with fuses and circuit breakers. Fuses can blow for a variety of reasons, including short circuits, overloads, and defective appliances. When a fuse blows, it is important to determine the cause before replacing it. If the cause is not determined and corrected, the new fuse will likely blow as well. Circuit breakers can trip for a variety of reasons, including short circuits, overloads, ground faults, and voltage fluctuations. When a circuit breaker trips, it is important to determine the cause before resetting it. If the cause is not determined and corrected, the breaker will likely trip again. Sometimes circuit breakers can trip due to nuisance tripping. This can occur if the breaker is not properly sized for the circuit or if there are voltage fluctuations in the electrical system. If you suspect that a circuit breaker is tripping due to nuisance tripping, you may need to consult with a qualified electrician to have the breaker replaced or the circuit rewired. Now let's consider some safety precautions to take when working with fuses and circuit breakers. Always turn off the power to the circuit before working on fuses or circuit breakers. This can be done by turning off the breaker that supplies power to the circuit, or by removing the fuse that supplies power to the circuit. Use a voltage tester to verify that the power is off before touching any wires or components. Wear appropriate personal protective equipment, such as safety glasses and insulated gloves. Never work on electrical equipment while wet or standing in water. If you are not comfortable working with electrical equipment, consult with a qualified electrician. Now let's talk about arc fault circuit interrupters, also known as FSIs, and ground fault circuit interrupters, also known as GFCIs. These are special types of circuit breakers that are designed to protect against electrical fires and electric shock. ASIs are designed to detect arc faults, which are dangerous electrical arcs that can occur when wires become damaged or loose. Arc faults can generate a lot of heat, which can ignite nearby materials and start a fire. ASIs are required by the NEC in many areas of the home, such as bedrooms, living rooms, and dining rooms. GFCIs are designed to detect ground faults, which are electrical faults that can occur when current leaks to ground. Ground faults can cause electric shock if someone touches a live wire or a grounded object. GFCIs are required by the NEC in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor areas. When considering upgrading your electrical panel, it is often wise to consider the benefits of ASIs and GFCIs for enhanced safety. Finally, remember to always consult with a qualified electrician for any electrical work. Electricity is dangerous, and it is important to have the work done properly to ensure your safety. In summary, while fuses are adequate overcurrent protection devices and permissible by code in many circumstances, circuit breakers offer convenience and potentially enhanced safety features such as quicker tripping and easier resetting. The homeowner should weigh the pros and cons and consider their specific needs and local requirements when making a decision about whether to replace a fuse panel with a breaker panel. And of course, any electrical work should be performed by a qualified electrician.